Okay, so today we're going to start talking about triangles and we're going to continue next class. So today we're going to go over triangle basics like area, types of triangles, and then we'll do some stuff with right triangles like the Pythagorean theorem and then special right triangles. So first we're going to go over the ho, mu, or k. So, which stands for homework. And these were the top 3 missed questions. So I guess we'll start with the first one. It was find the volume to the nearest hundredth using 3.14 instead of pi. So if you guys want to like put your answers on here with a post-it note or something, that's like perfectly fine.
But yeah, and I put the link in the chat.
Oh yes, I forgot about that. Oh, wait, does it say you can edit?
Yeah.
Oh, okay.
It should.
Yeah, it does. So this is a sphere, right? So we just basically use the equation for volume, which is 4/3 pi r cubed. So it tells us that the radius is 7. So I just put that in there. And then instead of pi, we're using 3.14. So I'm putting this in here. And well, there's no real like need for me to actually do this like by hand, so I'm just going to use a calculator. Is it 7? And my calculator told me that it is 1,436 times 0.026666, and then I just round to the nearest hundredth because that's what it tells me. So I get 1,436.03. Yep. And make sure you actually like read the question and round to the nearest hundredth, because you can definitely get points. Like you can definitely miss it after doing all the work, just not rounding right.
Okay, so this problem, we need to find the volume of this cone, and it's asking us to round to the nearest whole number. So the formula for the volume of cone is just the base, which is a circle, times the height, and then you multiply by pi, or not pi, sorry, you divide by 3 because it's a cone. So volume equals 1/3, and then the base is pi r squared, so pi r squared times height. Oh, it's not showing up.
Yes, it is.
Is it?
Wait, is it
lagging? Oh, okay. Yeah, sorry, it was lagging.
Oh, okay.
Yeah. So it says here that the radius is 8 and the height is 9. So now we just use our trusty calculator because I don't want you for these types of problems where you need to multiply, like using pi equals 3.14. I think you can usually use a calculator on these because otherwise it'd be kind of hard multiplying it out. So 1/3 and then multiplied by pi, which is 3.14, and then you multiply by the radius squared, so times 8, and then times the height, which is 9. So this gives us an answer of 602.88. However, it does, remember that it says you need to round to the nearest whole number, so it would just be 603.
Okay, the last one is finding the height of the cylinder. Wait, the height of the cylinder is 3 feet, and then finding the total volume of both the cone and the cylinder put together. So for this, there's no formula for finding like this weird shape. So I split it up into the cylinder and the cone. So I guess we can do the cone first, since we just did that. So I would do volume is 1/3 pi r squared h. So I'm going to put in 1.4 for r, and then 2.6 for h. So I'm just going to use the calculator, which gives me 1/3 times 1.4 squared times 2.6. I think I typed something wrong here. 1/3. Oh, I forgot to write times. It gives me 1.6986 repeating. I think I might do it again at the end. Maybe it gives you a whole number one. And then for the cylinder, it's just pi r squared h. So it tells us that this part is 3 feet. So that's the height of my cylinder. I'll just use this, put it in here. And the radius is the same as the cone, since this circle and this circle are the same, right? So then I put in 1.4 here. That gives me, oh wait, I forgot to type. 1.4 squared times 3. Oh. Gives me 5.885. And I guess I can just add these together. I'm gonna like do this all at once again, just in case it actually multiplies to.
They're both right so far.
2.6 times pi plus that gives me 23.81. It doesn't say where to round, but I'm just gonna round to the 100. Or yeah, you could use pi, but yeah. Wait, that's a 3, not an 8. Yeah, there you go. Okay, any questions? You just have to use the formula for all of these, so I think it's pretty straightforward. Okay, let's go back to our slideshow then.
Okay. So, as you probably know, today we're going to be focusing on triangles. And like for today, we're going to focus mostly on like some basic stuff, like, you know, what is a triangle, or like the different properties of triangles. So, but then in next week, we'll get more into the more complicated stuff about triangles. So first, what is a triangle? Well, it has 3 sides and 3 angles. That's a triangle. There's one other thing about triangles though that you should need to know, and it's that the angles in a triangle will always add up to 180 degrees. And we're not going to go into the proof right now, but this is a very important piece of information, and you need to remember this.
Yeah. Wait, I want to play it again. I didn't see it. So here are some triangle types based on like the length of the sides and the angles. So equilateral triangles are triangles that have congruent sides and angles. So the length of all of these sides are the same, and then the angle measures are all the same. That's what congruent means. It's basically like equal. And so if for this question, for this triangle, if all of the angles are equal, then how many degrees do you think each angle is in this triangle? Yeah, it's 60, because we just said that it adds up to 180. So then if I divide by 3, I get 60. And for all of these, like these little tick marks show that they're the same length. And then if you look at the blue triangle, the angle, like they can be like tick marks there too, but that shows that they're the same, they're congruent. For the blue one, it's called isosceles, and it's where two of the sides and angles are congruent. And here it's like the angle that's like the sides right here. It can't be like this angle and this angle is the same, and then this angle and this side is the same. It has to be these two. And then the last one is the scaling triangle, which it just has no equal sides and no equal angles.
There's a second way to classify triangles. So like the way that Kayang just explained uses the side lengths of a triangle to see if they're the same or not. You can also classify triangles based on angles. So acute triangles have all three angles are less than 90 degrees. Right triangles have one angle that is exactly 90 degrees. And obtuse triangles have one angle that is greater than 90 degrees. You can remember this by thinking that like acute is a cute little triangle with little angle measures, so it has the smallest angle sizes. Also, with right triangles, we indicate that an angle is right by a little square in that angle corner.
Okay, so this is just a little bit of practice. So pick two of the terms that we just learned, like the triangle classification, and describe this triangle. Yeah, it's a scaling and right triangle. You guys are right.
Okay, so here's something important. They say like I draw a triangle that has like side lengths 8, 12, and 22. Is there like a problem with this? I mean, you can probably already tell like there is a problem because we're asking if it's possible. And well, the problem with this is that this is not a triangle because the two shorter sides, like they won't like connect with each other. Like if you think like, I think there should be a diagram, but
Oh yeah.
yay. So basically, the longest side has length 22, right? But the two shorter sides combined only have a length of 20. So if you think about it, if you try to bend these sides together, they're never going to connect. So it's not going to be able to form a triangle. So in other words, in order for it to be a triangle, any two sides have to be greater than the third side. So as another example, say like I draw a triangle that has side lengths 8, 12, and 20. Would this be possible? Well, no, because in this case, on the two other sides happen to just be the exact same length as the third. So when you try to like bend them over to connect, they just barely touch, but they don't actually make a triangle. It ends up just being a line. So basically, in order for it to be a real triangle, the sum of any two side lengths has to be greater than the third, because that sort of like makes the two sides like poke up, I guess, which is that makes a triangle. If the three sides of the triangle are A, B, and C, then it would be A plus B is greater than C. Any two sides of the triangle have to be greater than the third. And that's how you distinguish like what can be a real triangle or what won't make a real triangle. This is called the triangle inequality theorem, but you don't need to remember that name because it just doesn't matter. You just need to remember that any two sides in a triangle have to be greater than the third side.
Yeah, sorry, 1 second. So we're just gonna do like a little bit of simple practice. So using the thing that we just learned about the side lengths of a triangle, just put these into categories of real and impossible triangles. So real triangles are like real triangles that can actually be formed, and then the impossible ones are like the sides that don't meet or that form a line. So you can just say like real is numbers, I don't know, 1, 3, and 6, and then impossible is 2, 4, 5, something like that. Fake triangle. 2 and 4 are the same. Let's see. 2, 6, 9, 14. You're right. They are the same.
That's okay. That means you have at least one answer if you get one of them right.
I'll give you like 10 more seconds. All right. So yeah, most of you guys were right. The 1, 2, 4, and 5 were real because for all of these, any two sides, when you add them together, is greater than the other side. But for 3 and 6, for example, 28 plus 31 is not greater than 64. And 3 plus 8 is not greater than 12. So these triangles would be impossible.
Okay, so now we're going to review how to find an area of a triangle. Hopefully this should be reviewed, but it's okay if it's not. So because it's pretty simple. Basically, the area of a triangle is 1/2 times the length of the base times the height. So what would be the area of this triangle? Yeah, you guys are right. This would be 12 because, again, it's 1/2 times the base, which is 6, times the height, which is 4. So that equals 12. Okay, we can do a few practice problems. So this first problem, just find the area. Nothing too complicated yet. Yeah, you guys are right. The answer is 54. And so the base would be 18, multiply the height, which is 6, and then don't forget to multiply by 1/2 or divide by 2. So 1/2 times 6 times 18 is just 54. So for the second problem, Sasha made a triangular frame out of wood. It has a base of 6 inches and a height of 2.5 inches. If she wants to cover the frame with fabric, how much will she need? Yeah, so you guys are right again. It has a base of 6, height of 2.5, so 6 times 2.5 times 1/2 is just 7.5. Hopefully this is easy because it should be. All right, so now we're going to do a harder problem, although in my opinion, it's not too much harder. It just has more steps. So 160 bushels of corn, don't know what a bushel is, don't care, can be grown per acre.
Nobody saw that.
Can be grown per acre. Rosie's land is shaped like a right triangle. Given that an acre is 43,560 feet squared, how many bushels of corn does she grow?
No, it is not that. Nobody saw that.
To solve, could we use a calculator?
Yeah.
Yeah.
Yeah, this one is a little annoying if you try to do it by hand.
Mhm.
I think this is the one I was talking about for the calculator.
Oh, yeah.
Wait, where did that go? I didn't press anything. Okay, I think by this point everybody has already seen it, so I guess I'll just reveal it.
Yeah. So
If you said you didn't see it, then I wouldn't have saw it. I was looking away for a second, and you just said that, and then I saw 1600s in the chat. So just
yeah. So first we need to find the area of this triangle, because just to reiterate, it says that you can grow 160 bushels of corn per acre, and an acre is 43,560 feet. So we need to find like the total area of the triangle and then divide by 43,560 feet to get the number of acres. Then we multiply the number of acres by the 160 bushels of corn to find like the total amount. So first, the area of the triangle is 660 times 1,320 divided by 2, which you can use a handy dandy calculator to do because I am not doing that by hand. Then we divide that big number we get by 43,560, which goes in nicely, and we find that this makes up 10 acres of land. And since you can grow 160 bushels in 1 acre, then when you have 10 acres, you grow 160 bushels times 10. So in total, it'd be 1,600 or like 1,600 bushels of corn.
Wait, what? Sorry, I don't know what happened.
Did it get stuck somewhere? Oh,
Is it there or no?
yeah, we can see it.
Okay. So now we're going to talk about special right triangles. So first, we're just going to talk about, like, before we actually go into it, just go over what these terms are. Hopefully this should be reviewed too. But on a right triangle, the longest side that's like opposite of the right angle is called the hypotenuse. And then the other two sides that are like adjacent to the right triangle are called legs. And then, hold on. The altitude is just a line drawn from a vertex that intersects the hypotenuse at a right angle.
Oh, I want to point out one more thing about that. So when you're finding the area of a right triangle, you want to like find the base and the height, right? But here's an important thing. The base and the height have to be like perpendicular to each other. So when you're finding the area of a right triangle, you can treat the base as like a leg and a height as the other leg because they're perpendicular to each other. But another thing you could do is that you could treat the base as the hypotenuse and use the height as the altitude, because they're still perpendicular to each other. So like if you like tilt your head this way, like you can see how like the hypotenuse could be the base and the altitude could be the height of a triangle. So you could find the area using that way also.
Yep. And the Pythagorean theorem is just a squared plus b squared equals c squared, and it tells us how to find one side of a right triangle when we know the length of the two other sides. So a and b and c are just like side lengths, where c is the hypotenuse and then a and b are the legs. So this is just their relationship. So for example, here we're looking for the hypotenuse, right? So the formula or the theorem was that a squared plus b squared plus, not plus, equals c squared. C is x, 12 is b or a, it doesn't matter. And then 5 is, I'm going to say a. So once we just solve it, we get 13 as x. Yeah, and you can also remember the triples. That'll come up in just a second. Oh,
Yeah. So we're not going to go into like a formal proof of why this works, but I just think this like visual is pretty cool. It may be lagging, but if you can see it, it's a person and there's like squares filled with water. One square is on the leg of the triangle, the other square is on the leg of the triangle, and the third square is on the hypotenuse of the triangle. And the two smaller squares add up perfectly to the larger square. And that's essentially what the Pythagorean theorem is, because you're just looking at the squares of the lengths of each side and they add up to the square of the length of the hypotenuse.
so just a little bit of practice. Problem 1 is solving for x. X is the length. Yeah, some of you guys can probably think of this one pretty quickly because it's a triple. All right, so here I just write my as x squared plus 7 squared equals 25 squared. And you have to make sure to put the 25 in like the C, but the x and the 7 could be switched if you wanted to. And I just solve for x, which gives me that x is 24. Number 2, Rob draws a diagonal line from one corner to the opposite corner on a square paper. If the sides of the square are 12 centimeters, find the length of the line to the nearest whole centimeter.
You can use a calculator.
Yes. No. Okay, so I just put it into my equation again with 12 as the legs. So for x gives me that it's around like 6.97056275 something. So we round to 17 since it says to round to the nearest whole centimeter.
Okay, so basically, some of you mentioned Pythagorean triples in the chat. Pythagorean triples are just sets of 3 integers that satisfy the Pythagorean theorem. So you might have already seen 3, 4, 5 come up. 3 squared plus 4 squared equals 5 squared. So the 3, 4, 5 triplet would be a Pythagorean triple. And 6, 8, 10, it also satisfies the Pythagorean theorem, so it would be a Pythagorean triple also. You also have 5, 12, 13, 7, 24, 25, 8, 15, 17, 9, 40, 41. There's others. There's an infinite number of Pythagorean triples. And if you, in math counts and stuff, generally like the smaller ones, like 3, 4, 5, 5, 12, 13, those are pretty much good. Like they have like, so whenever you need to like solve for the side and triangle, you can just remember the triple instead of having to solve the Pythagorean theorem every single time. Also, another thing is that if you multiply each number in a triple by a common factor. So for example, if you multiply the 3, 4, 5 triple by 2, that will give you a new triple. So that's actually where the 6, 8, 10 triple comes from. It comes from the 3, 4, 5 triple. You're just multiplying by 2. Yeah, that's what I just explained.
Now we're just going to go over some special right triangles. So this one is called a 45, 45, 90 right triangle. It's such a creative name, right? So that's because the 45, 45, and 90 are just the angle measures like you can see on the screen. So just like a simple question, basically, which one of these classifications fits this triangle? Equilateral, isosceles, or scaly? Yeah, it's hard to spell right, but yeah, it's isosceles. I don't think anybody spelled it right. Maybe like isosceles, but yeah, it is isosceles because two of the angles are the same. So, but well, what just happened? Okay, so and here it shows us that the legs of this right triangle are x, and then the hypotenuse in terms of x is x root 2. And the sides of an isosceles right triangle always have this relationship. And since like it's a right triangle and it's isosceles, that's why the angles are 45 each, because you have to divide by 2. So for example, try to find x here. And you don't have to like actually say like the decimal number. Yeah, so it's 5 square root 2. And we know this works because, well, if you just use the Pythagorean theorem, like if, let's say I just didn't know what that was, I can still just use the Pythagorean theorem, put in 5 for my legs, then find x, which gives me 5 root 2 anyways. So, but it's just a quicker way instead of actually having to calculate it every time.
The other type of special right triangles are 30, 60, 90 triangles. And as you can see here, the relationship between the legs is that the leg opposite the 30-degree angle, in other words, the shortest leg, let's just call that leg x. Then the hypotenuse would have a length that is twice the length of the shortest leg. So the hypotenuse would have length 2x. And finally, the other leg that's opposite the 60-degree angle, that would have length x times square root of 3. So where does this stuff come from? So basically, let's make two 30, 60, 90 triangles. And what type of triangle is this? Like if we just look at these two triangles together, what type of triangle is this large triangle? Yeah, all of you guys are correct. This is an equilateral triangle, and it is an acute triangle too. and each of its angles will have length 60 degrees. So that means that like you see that like midline that's sort of like dividing the equilateral triangle into the two right triangles, that sort of like divides the bottom side in half. So if the side of an equilateral triangle is 2x, then just the right half of it, that bottom leg, would have length x. So now if we know that one side has length x and the other side has length 2x, we can just use the Pythagorean theorem, which that would give us the third side as having length x times the square root of 3. So overall, just remember that the ratio of the sides is x for the smaller, for the shorter leg, 2x the hypotenuse, and square root of 3 for the other longer leg. So oh, sorry, you can go.
You go.
All right. So this first problem, find x in the triangle to the left. So yeah, all you guys are correct. So remember that in like a 30, 60, 90 right triangle, the hypotenuse will be twice the length of the shortest leg. So the hypotenuse is x, the shortest leg has length 2. So to get the length of x, you just multiply 2 by 2, which is 4. And for the second problem, now we're going to want to find the area of this same triangle. Okay, so most of you guys have gotten to understand this. So just do remember that the length of the longer leg would be you have to multiply the shorter leg by square root of 3 to get the length of the longer leg. In this case, the longer leg would be y. So to solve, you just multiply the shortest leg by square root of 3. So y would equal 2 times the square root of 3. So now that we know y, we can solve for the area of the triangle, because that would be 2 times y. So like 2, the shorter leg, times y, the longer leg. And then you have to multiply by 1/2. Don't forget to multiply by 1/2. So that would be 2 square root of 3 as the area of this triangle.
I thought the problem said to find y. Either way works.
Well, yeah, you need to find y to find the area.
I know, but I thought it was just supposed to be y, but I got lucky and the bottom one was 2.
Yeah, they're the same.
But how does that work? Where the length of one thing would be the area of the entire thing?
If one side is 2, then what happens that like you need to multiply, like you have y, right? Like, and to get the area, you multiply y times 2, but then you have to divide by 2 at the end because you have to multiply by 1/2 in like finding the area of the triangle. So
no,
they cancel out.
Yeah, no, I got that. I forgot that you also have to square it in the end because that's okay. No.
So now we're going to go over finding the area of an equilateral triangle. So we're going to kind of build off of what we just did. And so we just talked about that if you put two 30, 60, 90 right triangles together, it becomes an equilateral triangle, right?
So would it be 2x on the bottom?
2x, wait, 2x?
The variable we're using is s.
Yeah.
Oh, so 2s.
Well, look, remember in this, look at this diagram. We made it so that the
Oh.
length of the equilateral triangle is just s.
Yeah. This
Oh yeah.
is just s. So this, like half of it, the 30, 60, 90, the shortest leg has a length of 1/2 s now. And yeah, that was just the angle. So now can you figure out the height of this triangle, this vertical line? Somebody tell me what it is in terms of s. Yeah, so it's just now, remember that when I had, where did it go? Sorry. When I had like the same thing with 2x, x, then it'd be x root 3, right? So right now x is 1/2 s. So now this would be 1/2 s times root 3. So now we can use the height and the length of its base to find its area. So did that show up? Okay. Yeah, so here we just look at our base. This whole thing is s, and then our height is this, right? So it's in a different order, but it's the same thing. The height times 1/2 of the base, so 1/2 s, is equal to root 3 over 4 times s squared. So that's the formula for the area of an equilateral triangle. Okay. So now we're just gonna do a Jamboard for some practice problems. And Amy, can you put the link in the chat?
Sure.
I think this should be editable. Yes.
Okay, put the link down. Oh, it opened on slide 7. So
Oh, it did?
yeah, for you at least. I changed the link before you clicked on it. So
Oh, okay. Makes sense. Oh, okay.
do you want to go through like one at a time, or do you want to just let everyone work at their own pace? And
That's what I was gonna ask you. I think, what time is it? 3:55.
I think we can let people work on it through their own pace a little bit at first, maybe.
Yeah, okay. We can give you guys like, we also have a Kahoot, so we need to get to that. So how about like, how long should we give them? There's 10 slides, so 10 minutes, and we can go through it really quickly, I guess. Because or else people won't be able to solve everything.
Whoa.
That's like really fast. But
No, your screen was sort of like frozen for a moment. And then like I blinked and suddenly there were like 9 answers.
yeah, I don't know why it's being kind of slow today. But anyway, so we'll give you until like I guess 4:05 maybe.
Yeah. Also, some of you guys may recognize some of the questions on here. So if you've seen the question before in a math counts test or just from some other place, just treat it like you've never seen it before.
Yeah, so I guess we can wait until 4:05 and then we'll go through everything pretty quickly. Since
Okay.
a lot of you guys are like very comfortable. with
Whoa.
this. Yeah, wow. And you can put either like your name or your initials, or if you don't want to, you don't have to.
The hypotenuse of a right triangle is x square root 2, right?
For a 45, 45, 90 triangle, yes.
Okay.
So, Caitlin, are you like on your phone or like a laptop or a computer? Oh, okay. Can you see my screen? Okay, so then I guess I can try to like go through these, and for each of them, you could just type your answer in the chat. and I'll move to the next one if you want to do that. And I don't think it'd be a bad idea if you wanted to download the app. Like if you are planning to like keep using your phone, then because we use Jamboards a lot. So if you could, that's, oh, okay, you're outside. That makes sense. So yeah, if you want, you can like type your answer in the chat, or you could just wait like 2 minutes. We'll be going over it anyways. So yeah, yeah, there's only like 2 minutes. So. Oh, that's great. Yeah.
Try to answer some of the questions at the back, like number 7, number 8, number 9, number 10, because those are the types of questions you're probably going to be more likely to see on math counts. Like all the other questions are just asking you to find the area, but like the last 4 questions, you need to use your brain more. Also, even if you can't solve the questions, you can still put your thoughts into a sticky note so that other people can benefit from them, and then they can also help you.
This is kind of related to that, not really, but like whenever you guys take math counts tests, so if you're not sure about it, like you should still definitely put it down, because you never know if you're right or not. And since it's just like an open blank, like you don't get penalized for being wrong. So you should always put anything that you can like think of in the answers. Okay, it's 4:05, so
I think we should go over number 7, number 8, number 9, number 10.
yeah, probably.
Or at least some of those.
Okay, here's number 7. So I guess we'll start with this one. A lot of you guys have the same answer, so hopefully you guys are all right. Let's see. Square ABCD has a side length of 4. Okay. Now where's my pen? So this thing is 4. No. Sorry, my screen is really crowded right now. Okay, there we go. So equilateral triangle FCB shares a side with the square. Find the length of EF in simplest form. So this is what we want to find. So what I'm going to do is, first, I have no idea how to find EF, just like directly. So I'm going to start by using this equilateral triangle, finding this blue line that I just drew, and then subtracting it from 4 to get EF. So how do I find this blue line? Well, it's the height of my equilateral triangle is just like turned sideways basically. So it'd be like this. And well, I know that these two sides are also 4, and one of this is 2. And if I just look at this, then it's a 30, 60, 90 triangle, right? And we just learned that the hypotenuse is 2x, the shortest leg is x, and then the other leg is x radical 3. So this one would be 2 radical 3. So now I know that this thing is 2 radical 3. And I know this whole side length of the square is 4. So my EF length would just be 4 minus 2 radical 3, which is what like almost all of you guys put. So great job, guys.
Okay. Slide 8. Square ABCD has an area of 36 meters squared. Whoa. DE equals 2EC. What's the ratio of the area of triangle BED to the area of square ABCD? So for this, we're looking for a ratio. So we want the area of, okay, please stop moving things on top of the diagram. We want the area of, whoa, okay, this area. Okay, whoever's moving stuff, please stop. Okay, we're looking for the area of that light triangle in the square to the area of the whole square. So how do we find the area of this, of BED? So we need a base and a height. So the base of this triangle, we could use ED as the base. And then for the height of this triangle, we could use BC as the height. So that sounds kind of like a plan. So first we need to find ED. Our question gives us something. So it says that DE equals 2EC. In other words, ED is twice the length of CE. So also square ABCD has an area of 36, which means that the length of its side is just 6, right? So that means that CE has a length of 2 and DE would have a length of 4. In order so that ED is twice the length of CE. Next, we want the height of the triangle, right? And the height is just BC, which is just the side of the square, which is just 6. So that now we have the base of the triangle and the height of the triangle. So that means the area of the triangle would just be 6 times 4, and then you multiply by 1/2. So the area of the triangle would be 12. So now, but we're not done yet, because here's the thing. It's asking for the ratio of the area of the triangle to the area of the square. Luckily, we already have the area of the square, so we don't need to solve for it. So the area of the triangle over the area of the square is 1/3.
All right. So second to last question. The length of the hypotenuse of a right triangle is 41 centimeters, and the length of one leg is 9 centimeters. How many square centimeters are in the area of the triangle? Well, I'm not sure if this was on our slide as one of the triples, but you could just use the Pythagorean theorem if you didn't know it. But basically, it says this is 41, this is 9, this is not drawn to scale. But from my triples knowledge, I know this one is 40. Again, you can just use the Pythagorean theorem if needed. But now I just find the area of the triangle. So that's just 40 times 9 times 1/2, which is 180 centimeters squared.
Wait, is that like a triplet or can it be simplified? Wait, no, but
This-
it can't be simplified in Priscilla.
Yeah. And this is like what we mean by knowing that triplets can be really helpful, because if this was on the actual math counts test, I don't want to waste my time solving this by hand, because it wouldn't take too long, but I don't want to spend any extra seconds on this. So wait, did I just use the annotating tool? Oh, oops.
Okay, last question. So this says like a line is drawn across the corner of this rectangle. So this line. And it makes a pentagon and a right triangle. Okay, so this is the pentagon. The pentagon is like the big, oddly shaped part of the rectangle, which I've outlined in blue. And then the right triangle is that little piece sticking off. So we want the area of this pentagon. So don't try to directly find the area of this pentagon, because I'm not sure how I would do it. Like, it would just be too much work, right? So instead, what we can do is we can find the area of the rectangle and then subtract the area of the triangle. That's a really weird triangle. But that would just be easier, right? So let's do that. So we need the area of the triangle. So how do we get that? Well, we need this, we need the height, and we need the length. So the height is this part I remarked in red, and the height is just the difference between this longer side here and this short side here. So 12 minus 7. So the height would be 5. You can use like similar reasoning for like the base. It's just 25 minus 13, so that would be 12. So now we can basically find the area of this triangle. It's just 12 times 5 divided by 2. So that is 30. Okay, so we got the triangle. That's 30. So now we just need the area of the rectangle. And that's actually pretty easy. That's just 12 times 25, which is, dang it, I blanked out. Oh, 300. Okay, it's 300. So it's just 300 minus 30 now. So the area of this weird pentagon region that's really hard to find is just 270. So we didn't need to do any really fancy stuff to find the area of the pentagon. We just needed to find the triangle and the rectangle and then subtract them.
Okay, any questions about any of this before we move on to something else that I think most of you guys will like? No? Okay, so back to our slideshow. And as this very wise rectangle was telling us, when in the course of human events it becomes necessary to review mathematics, one relies on the almighty Kahoot. I think somebody asked if we are doing this, and yes, we are. What do you mean it's a bad quote? It's a very good one. Yes, it's very amazing. You're just jealous. You can't think of that on your own. Invented with no skill. Whoa, that's not very nice.
Oops, sorry, Kaya.
All right, we need to like get to this fast. So I'm gonna start in like 1 minute. Can you type because you can't join? That's that. You can like private message me or something so that you don't give it away to everybody. Yeah. Okay, I'm gonna start in like 20 seconds. So everybody join really quickly. Okay, I'm gonna start, but I think you can still join in the middle. So. Remember, the winners get points.
It might be lagging.
Oh,
Yeah, I don't see any question.
Oh, now we can see.
okay.
It's obviously green, no question about it.
Yeah. Good job, guys.
Wow, there's 2 letters.
This is, okay, never mind. I thought it was about spelling too, and I was about to say that's pure torture.
We should do that.
Yes, we actually should.
What is the correct way to spell isosceles?
That would be more of a spelling bee question.
Yeah.
Because what if in math counts you have to write isosceles, then they count it wrong because for some reason it's not multiple choice.
I was on iPad, so it's hard to do with the time limit. So I just saw isosceles, so I just clicked that one, but it was wrong because then part was isosceles and then another word.
Yeah.
A
Blue.
Good job, guys. Oh, oops.
Yellow, obviously.
obviously it's blue. Or just combined it.
You
It's
could like get 2. You could like have your iPad on like the meeting thing, get your phone and do like the Kahoot on your phone.
Or maybe like having like, when you click your home button twice, it pops up with the 2 different things. So you could just click like that from only one device.
Uh-oh, it's frozen. What? Try waving your mouse and see if that helps.
yes,
Try
Oh.
do it.
Oh, okay.
it's yellow.
showed now.
Obviously.
How would the longest side be 1 times more?
Good.
Wouldn't that just not work?
Yeah, that wouldn't work unless it was like equilateral, but then you wouldn't call it like the longest side because they're all the same length.
Okay, so this one I'm gonna go first since a lot of you guys put 2. Well, so in a 45, 45, 90, it's like this one, right? The isosceles right triangle. Oh, that's why that line is too long. Well, we said that it's like x, x, and then x root 2. So the longest side is this one, and it's root 2 times longer than x. So that's why it's red. Ooh, some change.
Uh-oh, it froze.
It did.
Yeah. Oh, now it's here. Oh, time's up. Oh, you skipped it.
It wasn't too interesting anyway.
Okay, yeah.
Because we might run out of time. So there's 25 questions, I think. Yeah,
That's probably another boring question. Or not.
it's very speedy.
It's more obvious.
Yeah, no, there's no way that this is up to scale.
Yeah, it's not.
food to say or
Also, I wouldn't have gone this unless you went over in class for that one problem.
Yeah, so you could just use the triple for this one since it's 9, 40, 41. Or use the theorem, which always works. Wait, did it? Why?
Is this a right triangle? That's not even a, oh shoot.
Couldn't you just done a true or false?
I don't know.
Good point.
it's a triangle, so I put it as a yes.
Uh-oh.
Guys, the answer is green.
Duh.
Oh, wow.
I mean,
Actually,
even-
this one isn't even a triangle because remember the
Yeah.
triangle inequality theorem. The two
Why
sides
is
have to
it-
be greater than the third. It's just not to scale at all.
Yeah, it's trying to trick you. So,
Yeah. Quick thing. In order for it to be a right triangle, it has to follow the Pythagorean theorem. For that one, 9 squared plus 4 squared does not equal 13 squared. So it wouldn't be a right triangle. The diagram is drawn, so it's a right triangle to try to trick you.
yes.
you sure it's drawn that way, or was the person who made it just want to just reuse the images and just erase it and
Probably
write
both,
the number?
Yes.
given that I was the one who made the image.
Is this a right triangle?
Uh-oh.
We can't see question.
Oh, it says 6, 8, 10.
Oh, there we go. Every time it freezes, one of us needs to yell that we can't see the question because the moment we say that, it's gonna change.
Yellow
Oh, I think I
equals
got it
yes.
wrong. Yep, I got it wrong.
Good job.
Image tricked me again. Well, not again, but still. Wait, how would you know that that one was a?
You could use like 3, 4, 5 and then multiply by 2 to get 6, 8, 10. Or you could just use the theorem and see if
Okay, if you didn't know the if one of them wasn't a Pythagorean triple you knew, or like ratio of that, could you find out or no?
you
Yeah.
can use the Pythagorean theorem, like a squared plus b squared equals C.
Oh yeah, because it only works in right triangles.
Oh no, if you go to the bathroom, you lose your
Just take your laptop to the bathroom. Easy.
It's frozen.
It is? Okay, I'll skip
Oh,
because we need time anyway.
It literally the second she said that
Yeah.
it confused.
How many questions should I skip? It's 420.
wait, how many do you have? Oh, skip
Yeah,
just go to the next one and see if it's good or not.
Okay, let's see if I like this or not.
Oh, well. it froze.
frozen.com.
Oh, I don't really like this.
Uh-oh, there's one. Okay, no one got it right. That's okay. Yeah, we're
Stop it,
skipping
Charles. I
questions.
know
Jake.
too.
Yeah,
Ryan.
true or
True or
false?
false?
Right triangle.
It's lagging.
Just do this.
Why didn't it work?
Wait, which one's true for the? Oh, never mind.
Oh,
Oh, okay.
I played enough Kahoots to know which one's true, which one's false. I could
What
just
if I switch
spam it.
them?
Yeah, that's also
You
very.
should do that.
Do a little bit of
And like
troll.
all
I
the
don't like to do it though, because then what if they trick you and they switch it up?
yeah.
If there's another one like this, I'm.
Here's a true or false.
Don't click it. Don't click it. Don't click it. Yeah, I did it.
Gotta hit it.
Another true or false.
I'm skipping.
Oh.
Easy.
Baron Iron. He clicked on.
You got an auto clicker.
Yeah.
Should I pull mine up?
Okay, this one's okay.
This one is okay. Yes, I agree.
Oh, we can't see the answers, I think.
Okay, red is
Yeah,
13, blue is
okay.
25, yellow is 11, green is 26. Red is 13, blue is 20.
Oh, we can see now.
Okay.
It froze again.
Oh no.
It's okay. We can still see the answers though.
Oh, this one.
I ran out of time. I didn't.
Yeah, I think it went a little fast, but basically, Just
just
realize it's like 724 diagonal. So it's, oh my gosh, that's really bad.
The square of 7 is 49, and
20.
24 plus 25 is also 49. So it's 45.
What?
45.
Huh?
25.
It's just dank. It's confusing.
Good.
I'm not gonna lie, you're probably
He's
not the best
teaching us
option for explaining.
confusion. He's teaching us confusions on the teaching of Chinese.
Yeah, I'm teaching you guys.
Yeah, I agree. Even in
It's the
class,
best
you just
strategy. Confuse everyone. They'll never know them. They'll be distracted.
exactly. No, he that's his plan. I mean, even in class, when some people didn't understand the problem, he went up there, explained
Exactly.
it, and then
Yeah, when
made
somebody
sort of confuse
doesn't
us more.
understand, I make
And the
sure they
teachers got
don't. I
mad.
make sure everybody doesn't understand. There can't only be one.
You should skip like 5.
Okay, I want to do this one.
You have to.
Okay.
This will be this.
We can't see the answers.
Oh, really? But already 6 people answered.
I'm
I
guessing.
guess.
What?
Maybe because they guessed.
Oh.
No, I guess.
Hey. It's what we deserve, though.
Oh no, I bet a lot of you guys guessed.
Okay, is it like impossible to get in
Oh
fourth
my
place or
gosh.
something? I'm stayed in fourth for like the last 5 questions, and I've just seen the people above me switch in and out and in and out.
They're interchangeable parts.
Are you skipping this?
Don't say anything, most people will guess. Yes.
Don't say when you're gonna skip it, because then people are gonna start guessing.
No, you didn't skip.
Yeah, I know.
First.
I thought half of you guys might think I would skip.
I just hit the wrong button.
So that's what you said.
Wow, 6 people still got it. What? Didn't change.
Okay, so I go down when I get it right.
How could you?
I'm gonna make you guys do this.
We can't see answers.
Frozen, yeah.
Oh no, okay. Red is 6, blue is 12, yellow is 18, green
Okay.
is 36.
We can see it now.
Okay.
You should probably skip like 2 or 3 more.
Okay, yeah, she said skip. Now we gotta guess.
No, you guys aren't.
It's
Just guess
guessing.
that one. I had no idea.
I am not skipping. Haha.
You actually would have had a better chance of saying, like, of not saying you were skipping. Like you weren't skipping, probably.
No!
Oh, who
What?
did that?
Who was that?
I got it right.
Who was that? Is it you?
Orion.
Did it.
Oh, okay. It's not.
I got a perfect 1,000.
Hmm. Ooh, I have a question.
I was like the third person to
I
answer.
just guessed
Hopefully it's
that.
better than the fourth.
I guessed somehow the right answer.
I'm the master of misclicking onto the right answer.
I think we said this in class. Yay, good job, guys. Let's go. Last question. Let's do this.
Oh. This is-
I wonder.
We did this in the quiz.
I spammed, but
You don't even need
I
the
know
answers.
it's false.
but I'm not sure.
I knew
Exactly,
I
it's
know
false.
it's red. I know. No.
Yes, it was. You didn't switch it up.
No. No. You didn't switch it up.
Why would they change it during the
I don't know. They probably thought that you guys are gonna
Problem. For like half
Come
the
on, what?
Only
How is
like-
that even possible? The person
Let's see what happened.
in front
I
of
got
me
it
got the
exact
exact same
1,000
score that I
again.
did, like on the
and
last
it
question.
froze. That's
Wait, it
feedback.
froze, Kayang.
Oh,
Bro,
really?
yo, it's so laggy. Everything keeps freezing, and then all of a sudden it just goes like,
Where is D? Who is D?
These
That's me.
Oh my
Did he-
gosh, Jamie.
Wait, replay it. There's
Okay.
a replay button somewhere.
Yes, I think so. Yeah, here we go.
Yeah, replay it because I didn't see the fourth place person.
the fourth place person was period.
Period? Who's period?
Period 6.
Oh no,
I'm
it froze
period.
again.
Points. Who is it?
Armand.
Period.
Armand.
Fourth place is
lag.
Lily Chiders.
there's just like disappear, and then the time runs out before you can answer them.
Yeah. Wait, so period is Armand?
Yeah.
Okay.
Wait, really? I thought I saw its actual name. Whatever.
I got like 6 questions.
Yeah, you guys can go. Remember, you have homework. Thank you for coming, guys.
Bye. Have a good day.
Bye everyone.
Bye, you
Thank
too.
you. Oh, and also winner AR is me, just so you know.
Yeah, we know that. So yeah, you guys can go. Bye.
Oh, you need to stop recording.
Good point.
I think that was